Welcome to The Explainer. Today, we're opening a highly fascinating and honestly kind of unsettling file on human behavior. Consider this your classified clinical briefing on what we're calling anomalous human responses, the Phobia Dossier. We're going to be looking at human fear not just as a fleeting emotion, but as a deeply embedded survival program. It's basically a piece of ancient evolutionary code that, well, sometimes severely glitches in our modern world.
Okay, let's dive into this. To really understand this glitch, we have to start with a massive central paradox. Why do subjects exhibit extreme biological terror toward a harmless house spider, but feel absolutely no instinctive dread when staring down the barrel of a loaded handgun? Think about it. A gun is objectively way more lethal, yet it rarely triggers that automatic, heart-pounding panic the way a tiny little arachnid does. So what's going on here? Let's investigate exactly why our internal alarm systems are wired this way.
Section 1. Classifying the anomaly. Let's separate normal human fear from a true phobia.
The baseline difference here is actually pretty clear-cut. Fear is a completely normal, rational, and temporary response to a perceived threat. It's a basic survival instinct. A phobia, on the other hand, is an excessive, entirely irrational, and persistent anxiety disorder. The clinical data specifies that to officially be classified as a phobia, this intense dread has to stick around for 6 months or more. It's a completely disproportionate reaction that goes way, way beyond simple caution.
When a phobia is actually triggered, the subject's physiological response is extreme. It's almost as if they've been infected by a bizarre, mind-altering virus. The body instantly activates a massive fight-or-flight adrenaline response. We are talking extreme sweating, drastically increased heart rate, and literally catastrophic thoughts of impending doom. Subjects even report feelings of detachment or depersonalization, where reality itself just feels distorted. These intense physical reactions completely override logical thought, basically forcing the person into extreme avoidance and safety-seeking behaviors. Section 2. Catalog of common phobias. Let's look at specific and social triggers.
Clinical records generally group these anomalous fears into 3 main buckets. First, we have simple or specific phobias. This covers the really common ones we all know, like acrophobia, the fear of heights, or ophidiophobia, the fear of snakes. But interestingly, it also includes incredibly niche ones, like dodecaphobia, which is the paralyzing fear of the number 12. I mean, wow, right? Then we have social phobias, like glossophobia, the intense fear of public speaking. And finally, complex phobias, such as agoraphobia, which is that deep dread of open or crowded spaces where escape might be difficult. And this brilliantly illustrates one of the most prevalent specific phobias recorded in our archival data, the arachnid. Arachnophobia affects a massive percentage of the population. Honestly, for a lot of you watching right now, just the specific shape and those long legs of the spider are probably enough to trigger a mild sympathetic nervous system response. But why? Why that specific shape?
Section 3. The evolutionary fear module. We need to look deep into our biological history. To answer that, research divides our fears into 2 distinct evolutionary stages. First, we have phylogenetic fears. These are incredibly ancient. They involved evolutionary threats that our ancestors faced millions of years ago, things like snakes, spiders, and heights. On the flip side, we have ontological fears. These involve modern, industrialized threats: hot stoves, electrical sockets, airplanes. The absolute key takeaway here is that our brains are hardwired to react to those ancient dangers, not our modern conveniences, even if the modern items are statistically way more dangerous to us today.
This whole concept is perfectly summed up by psychologists Oman and Maneka. They noted that evolution created a fear module within the mammalian response system designed to quickly associate certain entities as harmful to survival. So basically, this fear module is legacy code sitting right there in our subconscious. It's an ancient survival software program that kept early hominids alive in a seriously dangerous wilderness.
This is evolutionary preparedness in action, folks. Think about it. Our ancestors who quickly detected and feared predators, like a snake hidden in the grass, they survived to pass on their genes. The ones who stopped to admire the cute, scaly creature, well, they didn't. Because of that, we are literally the descendants of the highly anxious, hypervigilant survivors. We are biologically prepared to learn these specific ancient fears super rapidly. And this evolutionary programming isn't just limited to wild animals. It also dictates how we process social threats. The data on facial recognition adaptation is just fascinating. In controlled studies, mammalian subjects will spot an angry face in a sea of happy faces significantly quicker than they can find a single happy face in a crowd of angry ones. Our visual processing is quite literally biased. It's hardwired to lock onto social danger instantly,
long before it can actually cause us harm.
Section 4. Acquisition and social transmission.
So, the crucial point here is what researchers sometimes refer to as the amnesia protocol. You might be wondering why people so rarely remember where their intense fears even came from. Well, harmful encounters that lock into this primitive fear module often happen incredibly early in life, typically before age 2. Because of natural childhood amnesia, the subject grows up with a severe phobia but absolutely no conscious memory of the initial event that caused it. The fear is just securely locked away in the subconscious.
So, how do these fears actually spread? Clinical data identifies 3 primary vectors for acquiring these anomalies. First is classical conditioning, which is the repeated pairing of a neutral stimulus with a harmful or painful event. Second is observational conditioning. This one is huge. It's a child witnessing fearful behavior in a parent, like a mother reacting with absolute terror to a dog, and the child just downloads that exact same fear. And third, verbal threat transmission, which is simply receiving intense warnings from caregivers. This perfectly explains why you might be absolutely terrified of dogs while your best friend isn't at all. It all comes down to your unique transmission and conditioning history.
Section 5. The mushroom paradox. Now, I want you to pose this really unsettling question to yourself. If we evolved to automatically fear ancient things that could kill us, why don't we possess an innate, instinctual fear of mushrooms?
It is a massive anomaly. Poisonous flora, particularly mushrooms, posed a survival threat that was perhaps even greater than spiders and snakes throughout our evolutionary history. Eating the wrong fungus was a rapid death sentence for early hominids. And yet, despite how deadly they are, human infants will happily try to eat a mushroom they find in the dirt. We require strict, repeated conditioning to fear poisonous plants, which is completely unlike our instinctual jump-out-of-your-skin reaction to crawling creatures. Now, what's really interesting about this is how the paradox is resolved through cognitive schemas. It turns out our brains don't just fear raw statistical lethality. They fear specific traits. We possess mental schemas that organize danger based on an entity's speed, sudden movements, unpredictability, or whether it has discussed relevant traits associated with disease, think slime or weird, unusual limbs. A mushroom might be deadly, but it's predictable and stationary. A spider, it's fast, erratic, and completely alien. We fear the schema of unpredictability far more than the actual statistics of lethality.
Section 6. Containment and extinction protocols. How we overwrite fear.
Before we can extinguish a fear, we literally have to map out its feedback loop. This is known as the 5 areas maintenance cycle. It all starts with altered thinking, catastrophic thoughts like, I am going to die. That triggers negative emotions, like pure dread. That dread leads to intense physical symptoms, like hyperventilation. The subject then engages in unhelpful behaviors, which finally culminates in safety or avoidance behaviors. And here's the kicker. By completely avoiding the trigger, the brain is never taught that the trigger is actually safe. This means the avoidance behavior essentially guarantees the phobia is going to intensify over time.
And when clinicians actually try to break this cycle, they hit a wall called extinction resistance. Modern ontological fears, like say an acquired fear of electrical outlets, are surprisingly quick and easy to extinguish in therapy. But those ancient phylogenetic fears like snakes, and notably guns because of their directional danger and intense cultural framing as weapons, they produce strong phobic reactions that are stubbornly resistant to being unlearned. The primitive fear module fights back hard. So, how do we actively decommission this outdated fear module? Modern science relies on a few core protocols. Cognitive behavioral therapy, or CBT, is the primary tool used to logically break that vicious maintenance cycle we just looked at. Then there's in vivo exposure therapy, which is gradually facing the real fear in person. But perhaps the most fascinating modern advancement is the use of virtual reality machines. VR provides this highly controlled, safer, and much cheaper environment to repeatedly trigger and slowly desensitize the subject. It's essentially hacking the evolutionary code and overwriting it in real time. Which leaves us with a final, highly provocative thought to consider as we close out this dossier. If our deepest, most visceral terrors are merely ancient survival codes, software written for a dangerous natural world that largely no longer exists, what truly lethal modern threats are we completely failing to fear today simply because evolution hasn't had the time to write the code for them? It definitely changes how you look at the things you walk past every single day. Thanks for joining me on this explainer, and keep questioning what you think you know.